We now go to polynomials. These are algebraic expressions involving non-negative integer exponents of variables. Examples: 4s. The variable s has exponent 1, which is a non-negative integer. X squared minus x plus 2. And 5x squared y cubed. In this example, 5 is the numerical coefficient, while x squared y cubed is the literal coefficient. Non-examples: 4s raised to negative 1. The variable s has exponent negative 1, which is a non-negative integer. 4 over s. This is equal to 4s raised to negative 1, so we avoid variables in the denominator. 5x squared y raised to 3 halves. The exponent 3 halves of the variable y is not an integer. A polynomial is an expression that can be written in the following form: a sub n x to the n plus and so on plus a sub 2 x squared plus a sub 1x plus a sub 0, where each a sub I is a constant and each a sub I x to the I is a term of the polynomial. A sub n is the leading coefficient, while a sub n x to the n is the leading term of the polynomial. Degree of a term. It's the sum of the exponents of the variables in the given term. Example: find the degree of the polynomial 5x cubed y squared z. The exponents of the variables x, y, and z are 3, 2, and 1 respectively. The sum is 3 plus 2 plus 1, which is 6. Thus, the answer is 6. Degree of a polynomial. It's the degree of the term with the highest degree in the given polynomial. Example: find the degree of the polynomial 3x to the 5th minus 4x to the 4th plus 1. The highest degree among the terms is 5, therefore, the degree of the polynomial is 5. We now classify polynomials. Types of polynomials according to the number of terms. Monomial has one term. Examples: 10x and x squared yz. Binomial has two terms. Examples: 10 plus x and x squared minus yz. Trinomial has three terms. Example: x squared plus 2x minus 1. Types of polynomials according to degree. First one is constant, the degree is 0. Example is negative 1. Next, linear, the degree is 1. Example, 2x. Next, quadratic, the degree is 2. An example is 3xy. And cubic, degree 3, with example 5x cubed plus x squared minus 1. We now go to addition and subtraction of polynomials. Suppose we have 4 apples, and then 2 bananas, and then 2 more apples, and then 3 more bananas. Question: what is the total number of apples? So there are 4 apples plus 2 apples, 6 apples all in all. What is the total number of bananas? There are 2 bananas and 3 bananas, so there are 5 bananas. The key is to combine like terms and simplify. Suppose you have 4a plus 2b plus 2a plus 3b. You're going to combine like terms, so you have 4a plus 2a, and you have 2b plus 3b. Now, 4a plus 2a is 6a, while 2b plus 3b is 5b. So the answer is 6a plus 5b. We now go to column method. We have to arrange similar terms in the same column. Example: find the sum 9x to the 4th minus 2x squared plus 5x minus 2 plus 3x cubed plus x squared minus 2x plus 3. This is the first addend. You have to put a space for the missing term x cubed. This is the second addend. Now, negative 2 plus 3 is 1. 5x plus negative 2x is 3x. Negative 2x squared plus x squared is negative x squared. 0 plus 3x cubed is 3x cubed. 9x to the 4th plus 0 is 9x to the 4th. So the final answer is 9x to the 4th plus 3x cubed minus x squared plus 3x plus 1. Next example, find the difference. 7x cubed minus 5x squared plus x minus 4 minus a quantity 3x cubed plus 2x squared minus 2x plus 1. You have to arrange similar terms in the same column. There's a column for x cubed, for x squared, for x, and for constant. Now, negative 4 minus 1 is negative 5. X minus negative 2x is 3x. Negative 5x squared minus 2x squared is negative 7x squared. 7x cubed minus 3x cubed is 4x cubed. So the answer is 4x cubed minus 7x squared plus 3x minus 5. We now go to multiplication of polynomials. Distributive property of multiplication over addition. A times quantity b plus c is equal to ab plus ac. The idea is to multiply each term of a factor to each term of another factor. Example, find the product when 3x squared minus 5x plus 1 is multiplied by 2x plus 3. The first factor is the multiplicand, and the second one is the multiplier. We multiply each term of the multiplicand to each term of the multiplier, or vice versa. Now, negative 3 times 1 is negative 3. Negative 3 times negative 5x is 15x. Negative 3 times 3x squared is negative 9x squared. 2x times 1 is 2x. 2x times negative 5x is negative 10x squared. 2x times 3x squared is 6x cubed. We add these polynomials. Bring down negative 3. 15x plus 2x is 17x. Negative 9x squared minus 10x squared is negative 19x squared. And then bring down 6x cubed. So the final answer is 6x cubed minus 19x squared plus 17x minus 3. We now introduce some special products. The first one is the product of two binomials using the FOIL method. FOIL stands for the products of the first terms, outer terms, inner terms, and the last terms. Quantity ax plus b times quantity cx plus d is equal to acx squared plus adx plus bcx plus bd, which is also equal to the following expression. Example, find the product of 2x minus 5 and 3x plus 1. The first step is to get the product of the first terms. 2x times 3x is 6x squared. Next, for the outer terms, 2x times 1 is 2x. Inner terms, negative 5 times 3x is negative 15x. And then, last terms, negative 5 times 1 is negative 5. So the final answer is 6x squared minus 13x minus 5. Square of a binomial. Quantity a plus b squared equals a squared plus 2ab plus b squared. A is the first term and b is the second term. This equality means the quantity first term plus second term squared equals the square of the first term plus twice the product of the first and the second terms plus the square of the second term. The first equation is for the square of a sum, while this one is for the square of a difference. Examples, number 1, the square of x plus 5. Based on the first equation, the first term is x, and the second one is 5. Following the formula, the square of the first term is x squared, twice the product of the first and the second term is 2 times x times 5, and the square of the last term is 5 squared. So the final answer is x squared plus 10x plus 25. Using the method that we discussed before, x plus 5 times x plus 5. 5 times 5 is 25. 5 times x is 5x. X times 5 is 5x. X times x is x squared. So the answer is x squared plus 10x plus 25. The answer is the same as that of the more efficient way on the left part of the slide. 2. The square of 2x minus 3. Following the square of a difference, the first term is 2x and the second term is 3. Square of the first term minus twice the product of the first and the second terms plus the square of the second term. So the answer is 4x squared minus 12x plus 9. Product of sum and difference. The product of a plus b and a minus b is equal to a squared minus b squared. It's actually a difference of two squares. Example, find the product of 5x plus 4 and 5x minus 4. The first term is 5x and the second term is 4. All you have to do is get the difference of the squares of the first term and the second term. So you have the following. The final answer is 25x squared minus 16. Cube of a binomial. The cube of a plus b is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. If a is the first term and b is the second term, so the right hand side means that you have the cube of the first term plus 3 times the square of the first term times the second term plus 3 times the first term times the square of the second term plus the cube of the second term. The first equation is the cube of a sum, while the second one is the cube of a difference. Examples number 1, the cube of x plus 2. We refer to the first equation. The first term is x, and the second term is 2. Based on the right-hand side, you have to cube the first term, and then 3 times the square of the first term times the second term, plus 3 times the first term times the square of the second term, plus the cube of the second term. So the final answer is x cubed plus 6x squared plus 12x plus 8. 2 cube of 2x minus 3. We refer to the second equation. The first term is 2x, and the second term is 3. The first step is to get the cube of the first term, and then minus 3 times the square of the first term times the second term, plus 3 times the first term times the square of the second term, minus the cube of the second term. So the final answer is 8x cubed minus 36x squared plus 54x minus 27. Division of polynomials. Long division. We have p of x over q of x. P of x is a dividend, while this one is a divisor. Example, divide 2x squared minus 3 by x plus 2. Step 1. Write the polynomials in terms of descending powers of a variable, filling the missing term by 0. For 2x squared minus 3, the highest power is x squared, followed by x and then the constant. Since there is no term with variable x, the missing term is 0x. Step 2. Divide the leading term of the dividend, which is 2x squared, by the leading term of the divisor, which is x. So 2x squared divided by x is 2x. Next, multiply the answer to all the terms of the divisor. So 2x is multiplied to x plus 2. 2x times x is 2x squared. 2x times 2 is 4x. Next, subtract and bring down the next term. So you're going to subtract and then bring down negative 3. Step 5. Repeat steps 2, 3, and 4 until the degree of the dividend in step 3 is equal to the degree of the divisor. Negative 4x divided by x is negative 4, and negative 4 is multiplied to x plus 2. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. Then you're going to subtract. This one is the remainder, this one is a quotient, and this one is a divisor. The answer looks like the following: 2x minus 4 plus 5 over x plus 2. Synthetic division. We will only consider the case when the divisor is of the form x minus a. Example, divide x squared minus 4x plus 2 by x plus 1. First step, write the coefficients of the terms in descending powers of variable. So you have x squared, x, and constant. These are the coefficients, 1, negative 4, and 2 respectively. Then you're going to write a equals negative 1 in the corner. Step 2, bring down the leading coefficient. So you're going to bring down 1. Next, multiply the leading coefficient by a. In this case, a equals negative 1, and copy the result in the next column. So 1 times negative 1 is negative 1. Next, add the entries of the column. Negative 4 plus negative 1 is negative 5. Step 5, repeat steps 3 and 4 until the last column. Negative 5 times negative 1 is 5. 2 plus 5 is 7. If the dividend has degree 2 and the divisor has degree 1, then the answer is 1 degree lower and hence degree 1. The answer is x minus 5 plus 7 over x plus 1.